So the purpose of this video is to help solidify the idea of what is a function. A function, f of x, is a set of points where x is the input and f of x represents our output. To get the output of an x value, we have to calculate its f of x value. So we have to put it into our function that we've defined using an equation. And by doing the calculation, we get a value. And that value gives us the y coordinate, and that lets us put the point on the coordinate plane. So in a way, we can call the y-axis is now the f of x axis. And for each x value, we get a unique f of x value that lets us get this point that we place, okay? So again, the idea of a function is that every time I plug in a number to the function, I get one number that comes out. So as I said, we could take a look at this table to help us understand that. These x's are our inputs. I put them into the function, f of x equals x squared. So that tells me, okay, if 0 is my input, then I have to calculate f of 0. And then I'll do 0 squared, because that's what this function is defined as, x squared. So I square 0, and 0 times 0 is 0. And so the x value gives me my x coordinate, and the f of x value gives me my y coordinate, okay, which now we will call an f of x coordinate also. So if I was to say what is the value of f of x at x equals 2, we would say it's 4. What is the value of f of 3? We would say 9, right? So if I say what's the value of my function at x equals -2, it's 4. So we notice that the value of the function changes depending on what the output is, right? So the function doesn't have just one value in this case, right? A quadratic function has a different value depending on what the input is, right? So we want to understand that this is an infinite number of points. And this is why when we've been doing our graphing, we've only been graphing 5 points. Sometimes we graph 7 points. And we realize that there's a lot of points in between, and we're just kind of going on blind faith that we're drawing and filling them in correctly. But again, there's an infinite number of points, and so we can use something like Desmos to help us with that. All right. So the main purpose of me making this video was partly to talk about functions, but also to help us understand interval notation for our assignment today. I wanted to try a different kind of warm-up. And so this warm-up again today is going to be you guys hopefully watching this video. And I was going to try to have everybody lock in, watch this on their phone, on their Chromebook, and either watch the narration with the captions or to listen along with headphones so that you guys can make sure that there's less distractions and you're totally focused. And then when we're all done watching this, we'll move on to the next step. So you can hopefully see that there's a pattern that I created here, right? We start with this parabola right here that's colored black. We have this next parabola that's colored purple, this parabola colored red, and this parabola that's colored blue, okay? We can see that they all have a leading coefficient with the absolute value of 2, but the black one, for instance, has a -2, and this red one also has a -2. So those would be what we're calling concave down. Okay, and then we can see that the purple one has a positive leading coefficient, and the blue one also has a positive leading coefficient. So those would be what we were calling happy faces before, right? But now we'll call those concave up. So what I used to make sure that these parabolas would actually look the way they look, right? Here's what's going to happen if I get rid of all of these intervals right here. If I get rid of these things, we're going to have a bunch of other lines that extend farther. Okay, and we can see that that was not the pattern that I had intended, right? What I wanted the pattern to be was to have these two things join each other right at the point where they coincide, right? So at 2 and 4, I wanted these to cross. I wanted the purple one and the red one to cross right here at 4, and I wanted the red one and the blue one to cross right here at this point, 6, 0. So we've had this in our warm-ups lately where we want to learn how to graph, or on what interval, we've been saying for what x values, with this function right here that we're looking at, this parabola, -2, x minus 0, x minus 2. Okay, when would that be positive, right? And we said it would be positive when it was above the x-axis. So if I only wanted to show this part above the x-axis, then I would use these curly braces, and in between there I would put a compound inequality. And the numbers that I would want to place here would be 0 and 2. And we could see here that this gave us the function plotted only for values in between 0 and 2. It gave us all the outputs for that, and that basically results in this curve that's on the positive side of the x-axis. So I want to do the same thing for this purple one, but I want the opposite. I don't want this purple function where it's positive. I want this purple function in the negative part, right? And so in this case, the thing that happens is that I still want a compound inequality. And in this case, what we want is to have the places in between 2 and 4. So that means I want the x's that are less than 4, but greater than 2. Now in this case, I would want the values that are in between 4 and 6, right? So maybe I'm going to leave you guys a beat to think about what numbers am I going to write here so that I can have the parts that are in between 4 and 6, right? So take a beat to think about that. I'm going to close that curly brace, right? So we need 2 of them. This would be a 6 right here. And over here we would have a 4. Now again, if I want to get just this part in between these two so that I could have this pattern continue, right? We can see that it's kind of zigzagging like this, right? I want to get in between 6 and 8. So again, I need a compound inequality. And that means that I would need to put less than 8, right? X is less than 8 and x greater than 6. So we have a pattern here. And let's say that we wanted to continue this. I'm hoping that you would understand what I would do, right? What equation would I write next if I wanted to continue this pattern to this one, right? I would want my x-intercepts to be at 8 and 10. So I'm going to go ahead and copy this section right here and paste it. But I'm going to have to change these two numbers, right? I don't want 6 and -8 anymore. I want those to be -10 and -8, right? So now look, I have my two x-intercepts, but what's wrong, right? The pattern is broken, right? It should be going concave down and then concave up, right? So we can see that this is a happy face, but I want it to be a sad face, right? Concave down. So if I change this to a negative, then that works. But we still see that there's too much, right? So I want to clip off these ends of the function. I don't want this part of the function to show, and I don't want the output for these values greater than 10 to show. I just want to show the part in between 8 and 10, right? In other words, I want to show the part of this function that's positive. So what I'm going to do is, again, write a compound inequality. And I will put, don't forget to close the braces, I'll put a 10 here and an 8 there. Okay, so hopefully you can see the way that we can use these braces depending on the leading coefficient, depending on what we're looking at. It helps us figure out the part that we really want to see and the part we're thinking about, right? So we can see for each of them what's happening. So I think exploring this with Desmos will kind of be helpful, because we could write this down on paper and not totally be sure what we're doing. And at the same time, using the technology, you know, we can trust it too much, right? And we kind of lose sight of what we're doing. So we'll do a little bit of both with this project today. So again, I'm trying to make this video short so that you guys can understand something. So as I said, you know, this pattern was something that I'd try to have you guys continue. And if I was to make a new graph here, you know, you guys would be able to maybe come up with a pattern on your own, right? But I'm gonna go ahead and close and delete all of that work I did right now. And let's talk about one specific thing right here, right? Let's change this to, well, we can go ahead and work with this one. Let's just move it over a little bit, right? So let's just say I change this x-intercept to 2, and notice that when I have -2 and -2, this graph is actually never positive, right? Its x-intercept is right on the x-axis, right? Sorry, its vertex is right on the x-axis, okay? So it only has one x-intercept, and it's right here. But if I change this value from 2 to 4, now we see that we have 2 x-intercepts, right? So what would I do if I wanted to show the part of this function that was negative? All right, in this case, if I want to show the part of this function that was negative, then I would have to show 2 separate intervals. Instead of having a kind of one inequality, I'd have to make 2 separate ones, right? I would want to show the x values that are less than 2, right? And you can see it does that, and you see that it ignores graphing this part. Okay, but then I also want to show the parts that are x greater than 4. Now I want to show this side too. So to do more than one region, what you do is you put a comma, and then if I put x greater than 4, you can see that it shows us those 2 parts. Okay, so we can see that now we're looking at the parts of the function that are negative. So this would be a response to a question that we'll have on our upcoming assessment about this. So let's do one more example before we move away from this topic. Okay, let's say that I had some new numbers. So let's try 4 and 6 in here. All right, so we have 4 and 6. And let's say I said, instead of showing the parts that's negative, because we would have the parts in between 4 and 6 to show me where the function is negative, because that's where it's below the x-axis. Let's say I wanted you to show me the parts of the function that are positive, right? For what x values is the function positive? So for which x values is it above the x-axis? And that would mean everything but between 4 and 6, right? It's positive everywhere else but between 4 and 6. So that means for everything less than 4, our function is positive. And for everything greater than 6, this graph is going to keep going up. And we could zoom out and zoom out and zoom out and kind of try to show you what I mean. But this graph is going to keep going upward, right? A quadratic function only has one turning point, and we call that the vertex. So it's not going to turn around again. If I plug in a number like -20, we can see, right, we get a very zoomed out picture to try to see how high it would go before we see what's happening when I plug in -20. So let's zoom back in and take a look at what we wanted to see, right? What values would I want to put in my inequality, right? For what values is this going to be positive? And we had these numbers that we wanted to see, which were 4 and 6, right? So we need 2 inequalities, right? I want to show x less than 4, and then I put a comma, and then I want to show x that's greater than what? Greater than 6. So now we will be looking at the parts of the function that are positive. So notice the difference, right, between having 2 separate inequalities or one compound inequality to kind of explain the region that we're looking at for the parts of the x values, the parts of the x-axis that are going to give us positive output values, right? So here you go. Let's get ready for the next part of the assignment. But hopefully, if you need to rewatch this to try to, rewind it or something like that later on, this might be able to help you through the assignment. Because again, the big idea was these curly braces. Okay, so don't forget that you need those. And the comma in the case that we want to have more than one inequality for our function. So good luck working on this next assignment.